Page 464, number 29. Now what we're doing is we're introducing the idea of a direction angle. So it's very normal to have a picture like is shown where you know the magnitude of the vector and you're given the direction in terms of an angle. So we want the component form. So we're going to resolve the vector into its component form using this idea, using our trigonometry, where we're going to take the length of V times the cosine of the angle for the horizontal component and the magnitude or length of V times the sine of the angle for its vertical component. Kind of like, working backwards from creating a right triangle to find the adjacent side or the opposite side. So we're going to substitute everything we have because we have everything we need. We know that the magnitude is 18, and we also know that the value of the angle is 25 degrees. And please remember that that angle has to be made with the positive x-axis. So the picture is very direct, and it makes it very simple for us to do this problem. So substituting in, the magnitude of V is 18, and we're going to multiply that times the cosine of 25 degrees. And then we're going to take the magnitude of 18 and multiply that times the sine of 25 degrees. So putting that into your calculator and rounding it, because it's definitely going to be an approximation, we get that V is approximately 16.31 and 7.61. So if I wanted to check my answer, what I can do is use these numbers to find the magnitude of V based on those two numbers. And when I do that, if I square 16.31 and add that to 7.61 squared, and then take the square root of that, it comes out to be, let me put that up here, 17.99 plus more decimals. So it's pretty accurate. So I'm happy with my approximation.